Namaste to all my dear students. I welcome all of you in Antivide's YouTube channel. Today we are going to discuss electron-proton theory and reasons of its failure. We all know that the neutron was discovered by James Chadwick in 1932. But what are the constituents of the nucleus before 1932? Before 1932, electrons and protons were considered as its constituents. The theory that explained the existence of electrons and protons inside the nucleus was known as electron-proton theory. Before 1932, electron and proton were the constituents of the nucleus. At that time, this was not mere an assumption that electron and proton exist inside the nucleus, but there were certain convincing evidences that support this theory. Now let's see those evidences that validated electron-proton theory. First and foremost evidence was the beta decay. The beta decay supports our electron-proton theory before 1932. In beta decay, electrons are emitted from the radioactive nuclei. Electrons were detected experimentally. The scientists concluded that electrons reside inside the nucleus from the experimental observations. However, this was not the complete picture. There was something more interesting thing that was unknown at that time. I will explain that at later stage. Anyhow, this is beta decay. Proton and electron is emitted from nucleus in beta decay, and from the observation of this electron, scientists concluded that electron must be inside in the nucleus. Yes, we know that Sir J.J. Thomson and then Ernest Rutherford concluded that atom as a whole is a neutral entity. Atom as a whole is a neutral entity. This was proved by J.J. Thomson and then confirmed by Rutherford. At that time, electrons were considered inside the nucleus. At that time, electrons were considered inside the nucleus and the rest of them revolve around the nucleus. See, few electrons reside inside the nucleus and rest of them revolve around the nucleus in the fixed orbits. And we know that in 1913, the concept of fixed orbit was given by Niels Bohr. To understand it, let's take an example of nitrogen. And nitrogen was considered to have 14 proton and 14 electron. 14 proton and 14 electron. 7 electrons reside inside the nucleus and the rest of them, that is remaining 7 electrons, revolve around the nucleus. See, these all 7 reside inside the nucleus and rest of the 7 electron revolve around the nucleus in fixed orbits. So nitrogen is considered like it. The atom as a whole was neutral. Third thing, now let's talk about proton. From mass spectrum data, the mass of various nuclei was determined, and it was found that the mass of different nuclei was found to be whole number multiple of mass of hydrogen atom. Mass of different nuclei was found to be whole number multiple of mass of hydrogen atom. Here n represent whole number. It is not in fraction. Mass of hydrogen atom was known to the scientists, and we know that in hydrogen atom there is one electron and one proton revolving in. There is one electron and one proton. It contains no neutron. And at that time, the hydrogen atom was called proton. Hydrogen atom and proton were same thing. Sometime it was observed that there was slight change in the whole number. There is slight change in the values of n. This deviation was due to presence of two or more isotopes of the same element. This observation confirmed the existence of proton inside the nucleus. So, first two observations confirmed the presence of electron inside the nucleus, and last one confirmed the presence of proton inside the nucleus. So, this theory was propounded taking the support of these three strong evidences. But what happens? We all know that in 1932, James Chadwick discovered the neutrons in the nucleus, and this discovery negated the electron-proton theory. There are several reasons that nullify this theory. Let's see those reasons that established the non-existence of electrons inside the nucleus. Let's see the reasons that established the non-existence of electrons inside the nucleus. This is important thing. Reasons of failure of electron-proton theory. Or the question may be asked that prove the non-existence of electrons inside the nucleus. Let's see one by one. First and foremost major point was wave mechanical consideration. Wave mechanical consideration was a big blow to this theory. Second is nuclear spin. Third is nuclear magnetic moment. Fourth is finite size of electron. Next, fifth is wavelength. Then beta decay. Then Compton wavelength. And last one is electron-neutrino pairs. Let's see one by one these all reasons which invalidated this electron-proton theory, and these all reasons are important from examination point of view. Yes, wave mechanical consideration. Suppose an electron exists inside the nucleus. The uncertainty in the position of the electron should be equal to the diameter of the nucleus, which is 2 into 10 raised to the power minus 14 meter. You know what is the radius of the nucleus as determined by Rutherford and other scientists by using gold foil and other materials. It is 10 raised to the power minus 14 meter. So diameter is 2 into 10 raised to the power minus 14 meter. And if electron exists inside the nucleus, then the uncertainty in its position will be equal to diameter. According to Heisenberg's uncertainty principle, this is a quantum mechanical concept, we know it. Del x into del p is equal to h upon 2 pi, where del x is uncertainty or error in the measurement of the position and del p is uncertainty or error in the measurement of the momentum of the electron residing in, if it resides inside the nucleus, and h is Planck's constant. So the uncertainty in momentum of electron, del p is equal to h is equal to 2 pi into del x, which comes out to be 0.527 into 10 raised to power minus 20 joules second per meter. We know the value of Planck's constant, we know the value of pi, and del x is also given 2 into 10 raised to power minus 14 meter, diameter of the nucleus. It's very famous equation from relativity given by Albert Einstein. The energy of electron emitted from the nucleus will be equal to under root p square c square plus m naught square c4, c raised to power 4. Here p is momentum of the electron, c is velocity of light, c constant, 3 into 10 to the power 8 meter per second. M naught, rest mass of electron. The rest mass of electron is equal to, in a relativity, it is equal to m naught c square. And if we put the value of rest mass of electron, which is 9.1 into 10 raised to power minus 31 kilogram, and value of c, then it comes out to be 0.51 mega electron volt. So the rest mass of electron is 0.51 mega electron volt. This thing you have to remember always, because it is 0.5, and if we take its square, m naught square CQ4, then it becomes 0.025, smaller value, and this small value can be ignored. So we are left only with E is equal to PC, P square C square under the root becomes PC, whose value comes out to be 0.527 into 10 raised to power minus 20 joule. And if we multiply the value of C, then E comes out to be 10 mega electron volt. But we observed that, but we have supposed that if electron lies or confined in the nucleus, then it must have energy 10 raised to power 10, it must have the value of energy equal to 10 mega electron volt. But experimentally, what is observed? Experimentally, it is observed that in beta decay, the emitted electrons, the electrons emitted from the radioactive nuclei carry energies from 3 to 4 mega electron volt. It is experimentally measured energy of the electron in beta decay. But if we suppose that electron is confined or reside inside the nucleus, then it must have energy equal to 10 mega electron volt. So our supposition is wrong. Hence the observed result contradicts our supposition. This means that electron is not confined in the nucleus, not at all. We have supposed it, but its value comes out to be very large as compared to the value, experimental value. So this was a big blow to electron-proton theory given by wave mechanical consideration. Next is nuclear spin. Second point is nuclear spin. Now, it is it is well known principle in nuclear physics, we all know it, that in nuclei with even mass number, keep it in mind, that in nuclei with even mass number should have integral spin, and a nuclei with odd mass number should have half integral spin. It's a very important principle in nuclear physics. Those nuclei who have even mass number, they exhibit integral spin, and those nuclei who have odd mass number, they exhibit or shows half integral spin. Now take the example of nitrogen. We know that 14 protons lies inside the nucleus. According to electron-proton theory, 7 electron lies inside the nucleus, and 7 revolve in the fixed orbit. And spin of electron as well as proton is 1/2. And total spin of 21 particles lying in the nucleus, 14 proton and 7 electron. 21 particles, total spin of 21 particles comes out to be half integral. That comes out to be half integral. Experimentally, what is observed? Nitrogen nucleus have integral spin. It is experimentally observed that nitrogen nucleus have integral spin. But if we consider electron-proton theory, if we consider 7 electrons inside the nucleus, then we see that the total spin of 21 particles comes out to be half integral. But experimentally it has integral spin. A serious violation of the well-established principle. Hence, nuclear spin nullifies electron-proton theory. If we take electron inside the nucleus, then our well-established principle get violated. And this concept of nuclear spin negated the electron-proton theory. Third point, magnetic moment consideration. Let's see. We know that magnetic moment of electron as well as proton are measured in terms of Bohr magneton, Bm, Bohr magneton, and nuclear magneton, Nm, respectively. We know it. And 1 Bohr magneton mu b is equal to EH cross upon 2me. H cross is equal to H upon 2 pi. H is Planck's constant. And Me is mass of electron. And 1 nuclear magneton, Nm, which is represented as mu n, is equal to EH cross upon 2mp. H cross is equal to H upon 2 pi, and H is Planck's constant. And mp is mass of proton. If we divide these two quantities, if we divide first one with second, then what we get? EH cross upon 2 pi will cancel out, and mu b upon mu n is equal to mp upon mn. And we know these values. Mass of proton 1.67 into 10 raised to power minus 27 kilogram. And mass of electron, its mass of electron, Me, 9.1 into 10 raised to power minus 31. Then it comes out to be approximately equal to 1836. So, Bohr magneton is equal to 1836 times nuclear magneton. That is, we can say that Bohr magneton, which is associated with the electron, is about 2000 times more than nuclear magneton, which is associated with the proton. Now, if electron resides in the nucleus, then it must have very large value of the Bohr magneton. But the magnetic moment of the nucleus was found to be, and it varies in the range from, even vary in the range from -2 nuclear magneton to +4 nuclear magneton. Its value between -2 to +4. It is experimentally found value. But if we consider that if we take electron inside the nucleus, then it must have a very large value of nuclear magneton. But experimentally it is not observed. Therefore, magnetic moment considerations also nullify the proton-electron theory. Finite size of electron. The electron is assumed to be a sphere of finite size. It is taken as equivalent to a sphere of finite size, even negatively charged sphere. And for heavy nucleus, there should be large number of electrons inside the nucleus for heavy nucleus. Now, if large number of electrons reside inside the nucleus, the nuclear size of the nucleus will become larger than the experimental measure value. So, the finite size consideration of electron also nullifies this proton-electron theory. Yes, wavelength. Let's see. Now, if electron reside inside the or confined inside the nucleus, then according to de Broglie, there is a wave associated with every moving particle, every moving microscopic particle. Every moving microscopic particle is associated with a wave. And if electron resides inside the nucleus, then and if it moves inside the nucleus, then there must be a wave associated with it. And there must be a wave associated with it. And its wavelength is equal to h upon mv. M is mass of electron and v is velocity of the electron, h is Planck's constant. It was observed that lambda associated with electron, which is moving inside the nucleus, comes out to be larger than the radius or diameter of the nucleus. You can see in the imagination for understanding that if electron moves in the radius, then its wavelength comes out to be larger than the size of the nucleus. The wavelength of the wave associated with electron was found to be much larger than the size of the nucleus. You can see in the animation. So it was concluded that the possibility of electron residing inside the nucleus is very remote. It is not possible. If we take inside in it, then its wavelength is larger. Its wavelength was found to be larger than diameter of the nucleus. It's a very strange thing. So this also the concept of wavelength or the concept of wave mechanics even, which was given by de Broglie, also negates the electron-proton theory. Yes, beta decay. This was the main reason that which supports the electron-proton theory. Scientists observed the electron during beta decay and they concluded that yes, electron must be inside in the nucleus. But later on, it was observed that in beta decay, not only electron but its companion, which is called neutrino, is also released or decayed with it from the nucleus, and it is of two types. Proton may be converted into neutron, giving electron and neutrino, or neutron may be converted into proton, electron and antineutrino. This is beta decay. No doubt electron is emitted, but with it another companion, neutrino, was considered or observed by Pauling in 1930. This is a different story. So, the electrons are emitted during beta decay when the nucleus changes from one state to another state. Electrons are emitted. It is experimentally established fact. But they do not reside inside the nucleus. They are not part of the nucleus. They are emitted when the nucleus changes from one state to another state. They are emitted only under nuclear transformations. And nuclear transformations occur to gain the stability, to retain the stability of the nucleus. In such processes, proton may be converted neutron or neutron may be converted proton. That will depend upon the stability or the atomic mass of the particular nucleus. Electron is emitted only at that time. It does not reside inside the nucleus. They do not lie permanently inside the nucleus. They are emitted during nuclear transitions. And also the electrons and neutrino always occur in pairs. So this was all about the electron-proton theory and the major reasons of its failures. In next video, we will try to understand the neutron-proton theory and evidences that favored it. Thanks for listening and watching. Thank you very much.